This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to the discussion. Today we're diving into the world of interactive physics simulations, specifically focusing on a resource titled Inelastic Collision JavaScript Simulation Applet HTML5. It's a fascinating tool, and our guest is here to shed light on its capabilities and implications.
Indeed. This applet offers a powerful way to visualize a complex physics concept in an engaging and accessible manner.
The applet's accessibility is a key feature, isn't it? It's embeddable in web pages, making it readily available for online learning.
Precisely. The ease of integration into existing online learning platforms is a significant advantage. It removes barriers to access for students and educators alike.
And what about the interactive elements? How do they enhance the learning experience?
The interactive elements are crucial. The applet allows users to adjust parameters like mass and velocity, observe the results in real time, and even toggle full screen for a more immersive experience. The play/pause, step, and reset buttons provide granular control over the simulation.
So it's not just a static demonstration, it's a dynamic learning tool. Users can actively experiment and see the consequences of their changes. This hands-on approach must significantly improve understanding.
Absolutely. While the provided excerpt lacks the specific learning goals and teacher resources, the potential is immense. Teachers can use this applet to guide students through various scenarios, prompting them to predict outcomes and analyze results. The interactive nature fosters critical thinking and problem-solving skills.
And the potential for creating tailored learning experiences is significant. Teachers can design activities around the simulation, incorporating it into their lesson plans to reinforce key concepts.
The applet is part of a broader collection of open educational resources from Open Source Physics at Singapore. This context is important because it highlights a commitment to providing high-quality, freely accessible educational materials.
This aligns perfectly with the growing movement towards open educational resources, making quality education more accessible globally. The fact that it's part of a larger collection suggests a well-structured and comprehensive learning ecosystem.
The Creative Commons license is another key aspect. It allows for broad usage and adaptation, encouraging collaboration and further development of the resource. The credits given to the developers Juan M. Aguirre-Gaviria, Fremont Tang, and Lukang also highlight the collaborative nature of this project.
Transparency and attribution are vital in the open source world. It fosters trust and encourages further contributions to the project.
Let's delve into the core physics concept, inelastic collisions. The simulation effectively demonstrates the key difference between elastic and inelastic collisions, the conservation, or lack thereof, of kinetic energy. Momentum conservation, however, remains a constant regardless of the collision type.
So the applet allows students to visually grasp the concept of energy transformation during inelastic collision. The conversion of kinetic energy into other forms, like heat or sound, becomes readily apparent.
The simulation's user interface is intuitive. The provided instructions clearly explain how to use the combo boxes, options, and field boxes to adjust parameters. The quiz questions included in the document are well-structured and cover the essential concepts, allowing for effective assessment of student understanding.
The quiz questions are a valuable addition, providing a mechanism for self-assessment and reinforcement of learning. The inclusion of both short answer and essay questions caters to different learning styles and assessment needs.
The essay questions encourage deeper engagement with the material. They prompt students to consider real-world applications of inelastic collisions, fostering a connection between theoretical knowledge and practical scenarios.
This is crucial for effective learning. Connecting abstract concepts to real-world examples makes the learning more meaningful and memorable.
The comprehensive glossary of key terms is another valuable asset. It ensures that students have a clear understanding of the terminology used throughout the simulation and accompanying materials.
This is particularly helpful for students who may be encountering these concepts for the first time. A well-defined glossary removes ambiguity and promotes clarity.
The FAQ section addresses common questions about the applet's functionality, accessibility, and learning goals. This proactive approach anticipates user needs and provides readily available support.
This is a great example of user-centered design. By anticipating potential questions, the developers enhance the user experience and make the resource more user-friendly.
The extensive list of other related resources and simulations highlights the breadth of educational materials available through Open Source Physics at Singapore. This interconnectedness creates a rich learning environment.
This interconnectedness is a significant strength. It allows users to explore related concepts and deepen their understanding of physics principles.
In conclusion, the Inelastic Collision JavaScript Simulation Applet HTML5 is a valuable educational tool. Its interactive nature, accessibility, and alignment with open educational resource principles make it a powerful resource for students and educators alike.
The applet's success lies in its ability to bridge the gap between abstract concepts and practical application, fostering a deeper understanding of inelastic collisions and their real-world significance. It's a testament to the power of interactive simulations in enhancing science education. This has been a truly insightful discussion. Thank you for sharing your expertise and providing such a comprehensive overview of this valuable educational resource. Our listeners now have a much clearer understanding of the inelastic collision JavaScript simulation applet HTML5 and its potential impact on physics education.
My pleasure. I hope this discussion encourages more educators to explore and utilize this and similar resources to enhance their teaching practices.
It was a great discussion.